Welcome to part 2 of 3D Geometry Dash in Gdevelop. In this tutorial, we're going to be continuing what we started in part 1. If you haven't watched part 1 already, I highly recommend you watch part 1 as well as the 2D Geometry Dash video that I made, because this project is built off of those two previous projects. But without further ado, let's get right into it. Also, before we start making our first things, if you look down in the description, you should see a link to the assets, a Google Drive link, and you should download all of the assets in that folder so that you don't have to make anything yourself in this tutorial. Now, the first thing we're going to do in terms of getting our code ready is we're going to actually program the side movement of the player. Because in our first tutorial, we didn't have any side movement, so let's get that programmed. So I'm going to add this over the player jump. I'm going to click angle snapping and then put Shift A to create a new condition. I'm going to right click, add, and then add a new event group. I'm going to call this event group movement. Because not only is this going to be the side movement, there's also going to be the forward movement as well for the player. So I'm going to drag this over here, and I'm going to have an always condition because we want the player to actually move forward because our player is not moving. So I'm going to add an action, click into player, and then we want to change the linear velocity because there's a physics object. We could use X position, but since there's a physics object, we're going to use linear velocity. And I'm going to say equal to 350 at all times. Keep in mind, we're not adding it because if we were to add it, it would keep going up and up and up, and it would keep getting faster and faster and faster. But we want to keep a constant speed, so I'm going to put 350, and I'm going to preview. And of course, you can change the speed if you want to whatever you want. And while we wait for the preview to load, let's see. And as you can see, we're already starting to move, and it's jittering a little bit. That's because mainly my computer. If you see it jittering, it shouldn't be jittering on your end. It's just mainly my computer is kind of moving slightly slow because of me recording this right now. So now that that's added, let's get to the side movement. Now, side movement is extremely easy as well because all we're going to be doing is changing the Z position of the player. So I'm going to add a condition. I'm going to go into other conditions, keyboard, key pressed, and I'm going to put if right key is pressed. This is on the keyboard. And I'm going to add an action, and I'm going to click into click into player, and then pipe in Z position. And since we're moving to the right, we want to add Z position. We want to add the Z position. So we're going to type in Z. Don't worry about elevation. That's what it's normally used for. But in this case, we're not using it for elevation. I'm going to add a value of 4. Now, of course, I've already had these set values. You can set these to whatever speeds that you want. And I'm going to copy and paste this, and we're going to do the same thing for the left key. So I copy and paste this by right-clicking, putting copy, and then putting paste. I'm going to delete this. Instead of putting right, I'm going to put left this time. And for the Z position, of course, instead of adding it, obviously now we're going to subtract it. So now if I preview, I can now use left and right to move the player. Now you automatically see that there's an issue. First of all, let me stretch out this ground so we don't keep falling. I'm going to go into the seam editor and stretch this out really far so we don't have to worry about falling. So here we have it. It's really stretched out now. Now if I preview this, you're going to see that if we start moving to the side, we have a problem. We're now starting to float on air. And the reason we're floating on air is because Gdevelop, of course, is normally a 2D engine. So anything that we do in the Z direction, we have to simulate it because the engine is not taking that into account. It's still treating everything like it's 2D. So for our engine, this doesn't exist. Falling doesn't exist over there. So we have to specifically program that ourselves. So let's get into that. I'm going to, of course, click back into movement and then put Shift A to create a new event under that. And I'm going to once again right click and add a new event group. And we're going to name this event group side falling. And the way that we're going to do this is we're going to use a formula that detects how far the player is away in terms of Z position from this ground Z position. I'm going to use a formula that's flexible. And what I mean by flexible, that means no matter where we put this object and no matter what width, what height, what depth it is, no matter any of those, it will always be realistic in simulating the fall off. So we don't have to keep specifically programming new values for each and every platform. So this is flexible coding. So I'm going to drag this condition under side falling. And we want this to repeat for each instance of the ground. What do I mean by this? Basically, we don't want this to be specific for one instance of the ground. If I drag this piece of ground in, we don't want this event to only work on this ground and not be applicable to the other grounds. So that's why we're going to use something called repeat for each instance. And the way we access this is we're going to go to the top right, choose add a new event, and we're going to put we're going to put for each object. And you'll see that you can choose which objects you want the event to be repeated. In this case, I'm going to put, not only am I going to put, well, we're going to put ground for this case because the blocks are a little bit different. So we're going to not repeat for each instance of ground. We're going to repeat for each instance of the block. So let's just do this right now. So now we have it repeating for each instance of the ground. So let's start actually adding the conditions. Now we're going to add an or condition for whether or not we want the player to fall, because there's two instances and when we want the player to fall. And I'm going to start off with this. So let's go add a condition, go into other conditions, events and control flow, and I'm going to type in or. And we're going to put in or, and I'm going to add a sub condition. Now the first sub condition that we want, I'm going to click into the player. I'm going to type in Z position, and we're going to put Z elevation. And we want to check whether or not this is less than, ground. We're going to put ground dot, and we want to ask if the ground Z position. So we're going to put ground dot Z. And now that we have ground dot Z, we want to put minus 50. Now the reason I'm putting minus 50 is because this is from my testing. I've been debugging, of course, when I make the project, debugging to see the player's Z position compared to the object Z position to see when it should accurately fall off. And this is always working for flat objects. Keep in mind, this formula will work for the player and flat objects. I can't trust that will work on curved objects. Now the other condition that we want is we want the player to fall off when it goes to the right end of the platform as well. So I'm going to add another sub condition, player, and now I'm going to put if it's Z position. I'm going to once again put the Z. If it's greater than, we want to put now is greater than ground. We want to ask if the ground Z position, so we're going to put ground.z. And we can't just stop at ground.z because, let me apply this for a second. Let's hit OK here. We can't stop at ground.z because if I zoom in here, let me preview this. Right around here, this left edge is the ground Z. That's ground Z. It's always at this left edge when it's calculating what the Z is. When it comes to this right edge is based on not only the Z position, but it's based on the Z position plus the depth of the object, which means how thick it is. So that's why we're going to add a depth to the Z position of the object. So I'm going to put ground.z plus ground.depth. And this makes the code flexible, so no matter how thick our object is, this will always be accurate. So I'm going to put plus ground.depth, and that's it. And now we want to actually make the player fall. Now in order for our player to fall, the way that physics objects work is physics objects have a mask. If I double click to ground, and if I scroll down, you'll see that, well, in behaviors, that it has layers and masks. And masks are what control whether or not the game engine detects whether it's in collision with it. And we can deactivate masks using code. And if we deactivate the mask, our player will no longer collide with it. So now, since we have this set up, we want it so when the player matches these parameters, when it matches these conditions, we want to deactivate the mask of ground. So I'm going to type in mask. And you see enable mask. And the way that you disable a mask is you simply put for enable, no. And of course the mask, we only have one mask, so we want to put 1. And that's another reason why we use repeat for each instance of ground. Because if we didn't repeat for each instance of ground, that means when these conditions are completed for one ground instance, it will disable all of the masks for all of the pieces of ground. And you can already see why that's not good. So that's how we handle falling off a platform. So let's go test this. And now I can actually fall to the side. And you can see that when I fell to the side, I actually fell off accurately. And just to show you that this is flexible, I'm going to increase the depth of the ground to 300. And now it's thicker. And now if I slide to the edge, you'll see that I'm still not falling off. But now I fall off to where it's actually to the edge. So that's why you know this code is flexible. So now we want to have the condition back. We want to be able to enable the mask depending on when we're within those parameters. And the reason why we want to re-enable it is because there might be a situation where the player goes out of reach of the platform for a second and it disables the mask, and then we need to re-enable the mask. So if we jump and go back towards the platform, that the mask will be enabled again. So let's add a new condition. I'm going to put Shift A. I'm going to click this condition right here, and we're going to add another for each object. and this is also going to be repeating for each instance of the ground. Now, we're not going to use OR because in order for us, the mask to be enabled, 2 of these conditions need to be true. So the first condition that needs to be true, we're going to click into player. We're going to ask if the Z position, and I'm going to put if the player's Z position is greater than ground.z minus 50. Basically, we're doing the reverse of what we just did. Ground.z minus 50. And we're going to not put or, we're going to put and, because both of these conditions need to be true in order for our code to execute. We're going to put if Z position is greater than ground.z minus 50, and if the Z position, and I'm actually going to copy it here and paste it. And I'm going to just change the symbol, the sign, to less than ground.z plus ground.depth. And here we have it. Now, of course, we want to enable the mask. So I'm going to copy this once again, paste it here. And now we want to enable the object's mask. So we're going to put, for enable, when it asks enable, we're going to put yes. And just to show you, and if I jump back in, if I'm back in range, here it is. I can actually be colliding with the ground again. Because I'm going to show you, if I disable this code by pressing D, click into it, pressing D, if I jump out and then go back in, you'll see that I'll still fall through the ground because the mask is never re-enabled. So that's why we have this piece of code. So of course, the next thing we want to do is we want to actually start making the depth of the player. But before we make the depth of the player, we do need to add one thing that we forgot to add in the last tutorial. Now, if I preview this and I fall off, I jump off and I fall off, you'll see that I keep kind of spinning and spinning and spinning and spinning and spinning. And I forgot. The way that we're using this, I would need this in our previous tutorial, but the way that we're jumping now is that the player is always rotating at a set pace. So never mind what I was about to say. Let's get into the spike depth. Let's get directly into the spike depth. Now, of course, the first thing we need is a spike. And this spike is going to be a 3D model because we're going to use, of course, this 3D geometry dash. And I'm going to add a new object. And you can find this 3D object in the assets that I have in the link in the description, the Google Drive link. That's where you can find it. So we're going to put a 3D model in because you may think, why can't we use a 3D box? We can't use a 3D box to make prisms and cones and triangles like that. We can't use boxes for that, or they'll look really weird and they won't even be accurate. Their hitbox will be like a box. So let's get this right here. We're going to add a 3D model and we're going to call this spike. And I already have, of course, a 3D model somewhere in my files. You can get it from wherever you saved yours. I'm just going to go find my 3D models and do this 3D spike. I just simply made a little 3D spike in Blender. We want no lighting effects since our geometry has no lighting. And we want the width. I'm going to set the width and the height from my testing. This is what matches with our player. Of course, you can change these to however you see fit. But our spike size is going to be 75 by 75 by 75. So that's what's going to be it. And of course, the model origin, everything is fine. We don't need to do anything else here. I'm going to hit apply and I'm going to drag this spike onto the scene. And right away, you'll see that we now have a 3D spike. So this is good. Now that we have the 3D spike, let's drag it on the ground. And of course, it's not going to do anything because we didn't program it yet. So it's not going to do anything. But I do want to center this on the ground. And just a tip, if you want to see whether or not your object is floating, you can zoom up close or clipping with the ground. You can zoom up close and you'll get a more accurate view of how the object's going to look on the ground. I'm going to set the Z position. I'm going to add a little bit. I'm going to add like 10 or I'm going to add 25 actually. And hopefully that should make it more on center. But either way, now we have a spike. And of course the spike right here, we can't really do collisions with this because the way that Gdevelop is right now, of course, it can't ask for 3D collisions because it's really just a 2D engine. Because if it could do that accurately, it would be 3D. It would be a 3D engine at this point. So we have to simulate once again. We have to simulate the 3D collision. So how are we going to do this? Well, we need a 2D object that's going to work at the hitbox. So let's add that. We're going to add a new object. There's going to be a sprite. And once again, you can find this in the asset folder. I'm going to call this spike hitbox. And I'm going to add an animation and add a sprite. Now, of course, I'm going to find this in my very own files real fast. I'm going to speed this part up. So here we have it. We have the spike now, and this the spike hitbox. Now the spike hitbox size, Of course, I did this for my own testing. I don't want you thinking that these values will work all the time. Now, I'm going to set the size to 72 by 72. This is what the size is going to be. But once again, I don't want you thinking that this is what the size should always be. This size should be dependent on the size of your spike. And of course, you can use a little bit of math to try to calculate this percentage of it, like how much of the percentage of this spike is in the hitbox, if you know what I mean. But basically, this is going to be the size of the spike. So now let's actually start programming the conditions for the spike depth. So I'm going to close up all of these, add a new event, right click and add a new event group, and this is going to be called spike depth. We're going to drag this condition under spike depth, and now we want to check, first of all, the first condition that we want is if player is in collision with the spike hitbox. Because once again, this spike doesn't do anything. This spike hitbox is the one that's actually killing the player, not the black spike, just the red spike. So I'm going to add a condition to click player and put if it's in collision with spike hitbox. And make sure to not use this collision, because this collision is for two physics objects. This will only work if both of the objects are physics objects. But since our spike hitbox is not a physics object, we need to use this collision. So I'm going to put okay. Well, if it's in collision with not physics 2, if it's collision with spike hitbox, and because once again, we have to do a similar thing. Depending on the Z ranges of our player, we want to make sure that it executes the code because we have to simulate a 3D collision. And I'm going to add a subcondition, and I'm going to put player, and let's compare two strings. I'm going to go into other conditions, and this is another way to do what we just did a little while ago, but I'm going to compare two numbers, not two strings. And the first thing we want to compare is player.z. We want to see if the player.z is greater than, if it's greater than player dot, not player, if it's greater than spike.z, we want the spike z position, spike.z, and then put minus 120. Once again, these are from my testing. These values will need to be tweaked. These values will need to be tweaked if you decide to make the spike bigger or smaller. So just know that. Keep that in mind. And also the second thing, we want to compare another two strings. And we want to check to see if player.z is, I'm going to go closer into this. If it's less than, if player.z is less than spike.z plus the spike depth. And you can see we're doing a similar thing to what we did earlier. Spike.depth, which is the thickness of it, minus 30. Once again, this value of minus 30, and let's put it right here. I forgot to put spike.z plus spike.depth. And there's another way. You can either use spike.object3d depth, or you can just use the simple way of spike.depth, which is what you should use because it's shorter and does the same thing. So here we have this value of minus 30. Once again, this is dependent on the size of the spike. So this minus 30 value will have to be changed whether you make your spike bigger or smaller. So I'm going to click OK. And what we want to do if all these conditions are true, we want to simply delete the player. We want to delete the player. So I'm going to type in delete, and we want to delete the object. Now this is control the collision. Now one thing you'll know is that if we're making geometry dash, let's say we're trying to design a level, we don't want to have to manually place all of these spike hitboxes on all of the spikes, because not only is that extremely tedious, that also leads to inaccurate hitboxes based on the position of the spikes. So that's not a good thing. Once again, we have flexible code to help us with that. Now the flexible code that we're going to use for this is, first of all, we want the spikes hitbox to always be the size of 72 by 72. So I'm just going to put it right here just so you can see how it looks, because this basically matches with the object here. So this is pretty easy to program. I'm going to put, we want this to always happen, so that means we put a blank condition. I'm going to add an action, click into spike hitbox, and then type in size. We're going to type in size. And we want this to always be equal to 72 by 72. So we have it right here. And we also want the hitbox to always be hidden. But for now, I'm not going to hide the hitbox. Well, actually, I will hide the hitbox, so you won't be able to really see it anyway. So let's hide the hitbox so we won't see it. And that also helps with performance. So I'm going to click into spike and type in hide. So now it will never be able to be seen. And another thing that we want to do is we want to spawn the spike within a certain position of the spike hitbox, within a certain position of it. So we're gonna add first for each object, and for each object that we want to do, we want to put for each spike, not spike hitbox. We want to use the spike, and we want this to trigger once because we don't want to keep spawning spike hitboxes on it. So I'm gonna put in add condition, trigger once while true. And what we want to do is create a spike hitbox. So I'm going to type in spike hitbox, and we're going to create this at spike dot x because we want it to be the x position. This is for the x position of the spike hitbox. We want to spawn it at spike dot x minus 18. Once again, another value that is based upon how big your spike is. Is based upon how big your spike is. And for the y position, I'm going to put spike dot y, and then I'm going to put minus 12. So like I said, once again, these are positions. You can test. The best way to debug this yourself and change it is to create a 2D camera, which all you have to really do is deactivate the 3D camera and add in a 2D one. But you want to check to see how the spike hitbox looks in a 2D view and see whether or not it's positioned right. So that's the way that you want to debug and change things. And this is what we always want to do. So I'm going to hit preview. And now I can actually die to the spike. And I can also jump over the spike. And of course it's a little bit hard for me to play this because 3D geometry dash is not normal. I'm definitely not used to my own game. But I jumped over the spike. We can go around the spike without dying. Just to show you that we can jump around. It was hard, I just messed that up, but you can jump around the spike. Okay, so that's the spike depth. Last but not least, we have the block depth. And this is going to be the most complicated thing out of everything here, but it's still not going to be that complicated. It's basically almost the exact same thing. It's almost the exact same thing as the spike depth, just with a few extra steps. Now, when it comes to this block depth, and also just the physics of the block in general, let's first of all add a new event, and we're not going to paste this here. I'm going to right click and put add and add an event group. And the event group that we want to call is block depth. Once again, these are just names. These can be whatever you want, really. And I'm going to drag this condition under it once again. And of course, what we're going to need is a block hitbox. So I'm going to add a new object, add a sprite, and I'm going to call this block hitbox. Add an animation here, add a sprite, and this is going to be a regular 32 by 32 red cube. So this is the block hitbox that we have here. Now by default, our block hitbox, I forgot to change the size of this. Our final block size for this game, because the blocks are about the same size as the player, not exactly, but our block size is going to be 75 by 75 by 75. That's going to be, or maybe it should be maybe a little bit bigger than that. I'm going to put it 80 by 80 by 80. That's going to be our block size here. So here we have the block size. And this is how big it's going to be. This is a pretty good size. So now we have a block on the scene. And now we have a block hitbox. And our block hitbox by default is going to always be a size of 80 by 70. And the reason why it's smaller than the block itself is because in Geometry Dash, you have to have space on the block to jump on top of it. Because if you touch the block side, or you touch its bottom, or the other side of it, you'll die in Geometry Dash. But you can jump on the top of the block. So that's why it's smaller than the block size itself. So we can have space to jump on top. So now, spawning in for the block hitbox, we want to spawn in the block hitbox. I'm going to put add condition. Well, we already have a condition here, so let's keep this. I'm going to click into it first so we can spawn it here. And for each object, I'm going to put for each object of the block. And I want to trigger this once. This is similar to what we did with the spike hitbox. Trigger once. And I'm going to add in an action. So we're going to create an object, and the object that we're creating is block hitbox. I'm going to put block.x -2. Once again, this is setting an offset. This is all dependent on the size of your block and testing. You're going to have to test if you want to make it different. For the Y position, we're going to put block.y plus 6. That's what we're going to do for the Y position. So now I'm going to click in OK. And now that we'll have a hitbox that spawns for the block. And as you see, we're not dying at the moment. We're not even dying at all. And that's because I believe I made the block. Well, I didn't program it so the block hitbox actually kills the player. So let's program that now. So I'm going to just put Shift A here, add another action. And we're going to put the death condition now. So if player is in collision first with block hitbox, we can't leave it just like this because remember, Gdevelop is calculating everything in a 2D space. So I'm going to put and other conditions in control flow. I'm going to put and we want to check. So once again, we're going to use another flexible formula. Almost all these formulas I'm using here are flexible. So we want to put the Z position of the player. We want to compare this with a value. So I'm going to put Z. If the Z position of the player is greater than, and what we want to check it whether it's greater than is block dot Z, if the Z position of the block, minus block dot depth. Block dot depth. We want to check if it's greater than that value first, and if it's less than. If it's less than, so I'm going to put copy, and we're going to paste it here. And if the player is Z position is less than block.z plus block.depth. So we're going to just keep everything the same except for this minus and put plus. And if all of these conditions are true, then we want to actually delete the player. So I'm going to put player, and I'm going to type in, of course, delete. We want to delete the player. And just to test that everything works, I'm going to make this ground much, much thicker. And I'm going to set this, go farther back, so we can have some bigger ground. You'll see that first we have a block here. And I'm going to put everything more centered in on this ground. So I'm going to change the Z position of this to 500 and set this block Z position also to be 500 so we can center this more. So you'll see that we can jump over this block, and that's good, but I want to show you that we can actually die to the block as well. So I'm going to crash to the side of it, and you'll see that I die. And just to prove that we can go around it, I'm going to go around the block, and you'll see that we have an issue right here. That's the issue I want to show you. That's because once again we have to program it so the blocks max are disabled depending on certain conditions. So let's go program that right now. So I'm going to click into this event, press Shift A to add another event under, and let's start. First of all, let's get a condition to activate the mask. So I'm going to add a condition. I'm going to click into player and type in Z. If the Z position of the player, first of all, is greater than, if it's greater than block.z minus block.depth, and we really just put this code in. We literally just put this code in. So minus block.depth, and I'm gonna just put it right here. It doesn't really matter whether you use this condition or another one. Minus block.depth, and add a condition, and I'm gonna put in other conditions, events and control flow, and we want to check. I'm gonna copy and paste this right here. If player Z position is less than block.z plus block.depth, now we want to enable the mask of the block. Because once again, this is a physics object. That's why we made these physics objects and not just regular 3D objects. We want to enable the mask. Of course, we only have one mask, so we're going to put mask 1. And yes, we want to enable it. And now for the second one, we're going to have to use or instead of and. So the first thing we're going to do for the second one, we want to disable the mask dependent on whether two conditions, if either of those are true. So I'm going to put events and control flow, or I'm going to click OK, add a sub condition. And what we want to check first is I'm going to click into player, type in Z, and if the Z of the player, we want to first of all check if it's less than block.z minus block.depth. Once again, we put this in already. We're really repeating the same thing. And now we want to also check if it's greater than. So I'm going to copy and paste this here. Or if it's greater than, so we want to switch this less than symbol to greater than. Make sure don't forget that. If it's greater than block.z plus block.depth, I'm going to copy and paste this. And now we want to disable the mask. So I'm going to put no. And here we have it. This should work if everything is programmed right. I can now pass by the block. I can go around the block. And once again, this is flexible code. No matter where the block is, this code will always work. So that basically is 3D Geometry Dash with the cube. That is how you make 3D Geometry Dash in Gdevelop. I hope you all enjoyed this tutorial. And if you want more tutorials like this, if you want more parts of the 3D Geometry Dash, because Geometry Dash has many more transformations, you can put that down in the comments below. And if this video gets to, I'd say, if this video gets to 40 likes, I'll make up another part of this geometry dash where you have a ship transformation. But that's only if enough of you want it. But I want to thank you all for watching once again, and make sure to always comment down below what tutorials you want to see next. Also, I'm going to shout out to the member and my member in the description. If you want to support the channel, make sure to become a member only for $1 a month, and you'll get access to special perks. But if you don't want to become a member, you can also subscribe to the channel. It's completely free, and hit the notification bell and like the video so you never miss out on any of my new Gdevelop tutorials. Once again, I'd like to thank you all for watching, and I'll catch you in the next tutorial. See ya.